Upbeat, mysterious music starts and fades into the background. Picture this: a spacecraft hurtling through the void, carrying a treasure chest not of gold, but of time itself. This isn't a sci-fi movie. It's the incredible true story of NASA's OSIRIS-REx mission and the secrets it brought back from a distant asteroid named Bennu. What did NASA find inside this cosmic time capsule? The answer is more astounding than you might think, and it involves a little bit of unexpected drama. Stick around as we unbox the mysteries of the solar system. On September 24, 2023, after a 7-year, 4 billion-mile journey, a small capsule blazed through Earth's atmosphere at over 27,000 miles per hour. It parachuted down into the Utah desert, carrying a precious cargo, rocks and dust from Bennu, an asteroid that's been orbiting the Sun for 4.5 billion years. This is the first time the United States has ever brought back a sample from an asteroid, making it a monumental achievement in space exploration. Why go to all this trouble for a few handfuls of space rock? Because Bennu isn't just any rock. It's a remnant from the dawn of our solar system, a pristine piece of the puzzle of how planets, and maybe even life, came to be. The OSIRIS-REx spacecraft, a marvel of engineering, arrived at Bennu back in 2018. It spent years mapping and studying the asteroid's surface, looking for the perfect spot to perform a daring maneuver called Tuchango, or TAG. In October 2020, the spacecraft descended, extended its robotic arm, and for a few heart-stopping seconds, made contact with Bennu. It fired a blast of nitrogen gas, stirring up rocks and dust, and capturing them in its collection head. The collection was so successful, in fact, that the container was overflowing, jamming the lid slightly ajar. A little bit of the precious sample was trickling away into space. Mission Control had to act fast, stowing the sample securely for its long trip home. So, what's so special about this particular space rock? Bennu is a carbonaceous asteroid, which means it's rich in carbon, the fundamental building block of life as we know it. Scientists believe that asteroids like Bennu may have delivered water and organic compounds to a young Earth billions of years ago, setting the stage for life to emerge. By studying the Bennu sample, we can look back in time. We can analyze its chemistry and mineralogy to understand the environment of the early solar system. It's like having a perfectly preserved chemical recipe for a planet. Finding water-bearing minerals, for example, could confirm that asteroids were the celestial water delivery service for our world. Back on Earth, the sample canister was transported to a specially designed clean room at NASA's Johnson Space Center in Houston. The excitement was palpable. Scientists were about to open a package that had been sealed for 4.5 billion years. But then, they hit a snag. Remember that overflowing sample? It had created a bit of a mess. Some of the bonus material, black dust and debris from outside the main collection head, had gotten lodged in the container's mechanisms. 2 of the 35 fasteners on the lid simply wouldn't budge. Imagine the tension. You have this priceless, pristine sample, a key to understanding our origins, and you can't get the box open. The material is so delicate that it must be handled in a nitrogen-purged glove box to protect it from Earth's atmosphere. You can't just grab a wrench from the hardware store. The team had to go back to the drawing board. They had to design and manufacture entirely new tools, made from specific surgical-grade stainless steel, that could safely operate within the confines of the glove box, and get those stubborn fasteners off without contaminating the sample. While the main sample remained tantalizingly out of reach, scientists got to work on the bonus material they could access, and what they found was immediately breathtaking. Using scanning electron microscopes, X-rays, and infrared instruments, they discovered an abundance of carbon and, most excitingly, water. The preliminary analysis showed that water is locked away within the structure of clay minerals. This is compelling evidence that Bennu's parent body, a much larger asteroid from which Bennu broke off, once had liquid water. It's a huge clue in the story of how water became so plentiful in our solar system. Finally, in January 2024, after months of painstaking work, the team announced their success. The new tools worked. They had finally opened the main sample container, revealing the core collection of rocks and dust from Bennu's surface. The treasure chest was open. Now, the real science could begin. The sample, weighing about 250 grams, will be meticulously catalogued and distributed to science teams around the world. For decades to come, researchers will be studying these tiny fragments, unlocking secrets about planetary formation, the origins of our oceans, and the chemical precursors to life. What's amazing is that NASA is only analyzing a small portion of the sample. A full 70% is being preserved for future generations. Imagine scientists 50 years from now, with technology we can't even dream of, being able to analyze these same rocks with newfound precision. The OSIRIS-REx mission isn't just a mission for today, it's a gift to the future. It's a legacy of curiosity and a testament to human ingenuity. From a daring space heist billions of miles away to a high-stakes engineering puzzle right here on Earth, the story of the Bennu sample is a reminder that the biggest discoveries often come in the smallest packages, and that the quest to understand our place in the universe is a journey that never ends. Thank you so much for joining us on this cosmic adventure. If you were fascinated by the story of Bennu, make sure to hit that like button and subscribe to our channel for more incredible stories from the frontiers of science and space. Let us know in the comments what you think is the most exciting potential discovery from the Bennu sample. See you next time.